Hello everyone. Has your manager ever asked you to improve the performance of your application saying that I need this resource or this page to load 2 times faster, 3 times faster, or 5 times faster because the user experience is at stake? Well, if yes, then you may be the only one here relating to it because I know the concept of caching pretty well. And I'm going to teach you so that you can make your applications much more performant, much less latent, and that is simply why we are here. So you may ask, what is caching, why do we need caching, when can we use caching, and all these questions will be answered as you watch this video. So just stay tuned and watch till the very end. Now let's try to imagine a certain situation. Let's say we have the World Cup final between India and Australia taking place today, and we go on to put on our TV or whatever platform we're watching it on, but suddenly there is an outage throughout the city. There is an outage across the whole city. We have no internet. There is no way for you to watch the match. Of course, it is frustrating and there is no solution for this, unfortunately. But what ends up happening is that as soon as the match ends, you go over to your browser and search for the scorecard. Now, thing is that, like I said, there is a city-wide outage of internet. So as soon as the match ends, the internet comes back on right that very instant. Everybody is rushing to see this very scorecard, and it is a sad, sad scorecard. But that should not distract you from why we are here, why you're watching this video. So you see on this page there is a lot of information present. You see that there is, for our team, we have the list of batsmen, how they were, how their wicket was taken, the number of runs scored, and all these other statistics on this very page that I'll let you see on the big screen. Same for the other team. This is the bowling stats. We have the batting stats for Australia, bowling stats for India, and there's just a lot of information. So all of this data is fetched one by one. It is compiled and then returned where we can see this on our browser, on our very screen. Now, it's not just you who is looking at the scorecard, is it? It is thousands or lakhs or millions of people who may be requesting for this very scorecard at any given point in time. So do you think in our usual setup being us having a server which is connected to a database, do you think in our usual server where we have so many clients, some of them could be on laptops, some of them could be on mobiles, doesn't matter, all of them are requesting this server for the scorecard, do you think it's a wise idea to get all of this information about the batsmen, the bowlers, the statistics, combining it for each and every request made by each and every client? I say that instead of computing all of this data again and again and again, we can use something called caching. By caching, what I mean in very, very simple terms is I compute an answer once. I compute an answer exactly once, then I store it on my server. My scorecard can be stored on my server so that whenever some new client requests my server for the scorecard, I do not need to make this call to my database and just return the scorecard directly from here as it is. Now you can keep this stored in memory, which is on the server itself, or you can use an external server or an external cache to achieve this. Now the question is, why is this necessary at all? So to answer that is very simple. Caching helps us achieve a few things. The first of which is that it helps us reduce database calls or network calls. So the very obvious question that you may have now is, why do we need to reduce database calls? I mean, that is where our data is, right? So why are we reducing these calls or these network calls? What even are they? So basically what I'm trying to say here is database calls are slow. That is the gist of it. Whenever you make a query to a database, it goes over the internet, it gets it from the memory, it returns it to you. That is a bit of a slow process. And network calls in general can have a little more overhead. They will add some overhead in terms of time, so that will make your API more latent. It will make it slower. So we want to reduce these database calls as much as we possibly can. And that is one thing. Second, what we want to reduce is computation. Like I mentioned, when you're trying to get a scorecard, you have to get the list of batsmen, bowlers, all these statistics. You have to combine them in one neat format, then return it back to the user so that they can see it on their screen. Like I said, we computed once and then we don't need to compute it again. That is why we do this sort of process, store it in our cache and keep it there so that the final answer is stored and we can just fetch the final answer whenever we want instead of calculating it again and again and again. So you may ask, okay, why do we need to do this? I mean, the scorecard, it's just for one match, for one tournament. I mean, how much data can there possibly be to, for us to need caching in the first place? I said, okay, then think bigger. Think of an exam, let's say an international exam that is taking place. That exam could have millions of users and you want real-time updates. Let's say some company has been assigned the task of calculating the real-time average of each user's score as and when they submit their test. Let's say some company is responsible for calculating this and displaying it on a website. Let's take this one hypothetical example. Do you think it makes sense for that company to constantly fetch all the records, all millions of records, sum them up, calculate the average based on the total number of students or users, and then send the response back to the student every time the website is opened? It doesn't make sense, does it? So it does make sense that you cache this result, keep it there, and you simply don't change it till the next result comes in. That is where we reduce computation, and there are millions of examples, millions of use cases where so many companies use caching for their own use cases. For example, if you're using Instagram, let's say there is a celebrity that has uploaded a picture of their own and their comments, the comments on their picture are very, very popular at the moment. They're going viral basically. So if a lot of people are accessing comments of that particular picture, under that particular picture, you have the option of caching those comments so that they are fetched faster from this server. Alright, so that is basically the concept behind caching. You keep the final answer stored, you don't have to fetch it from the large number of records that you may have in your database, and you return it, and you can achieve that by storing it as a key value pair. So the key is basically an identifier and value is the corresponding, well, answer or response. So then an identifier, for example, can be something like India versus Australia, and the answer can be your scorecard, all the data inside the scorecard, or it could be something like user average, and the answer could be something like 1000, something like that. So that is basically how you store it in key value pairs. Whatever value you need, you search for its key and the answer will be returned to you accordingly. Alright, so your first instinct may say, okay, then why don't we just store everything inside the cache? Why can't we simply do that? Why do we need databases at all? Well, there are a few reasons for that. The first of which is that caching is expensive. And not only is it expensive, there is a limit to it. And of course, that limit is usually associated with money. The more you can pay, the more you can upgrade your hardware. But let's say your database company allows you to store terabytes and terabytes of data, if not hundreds of gigabytes, let's say, hypothetically. Your cache will be limited. It can be, comparably speaking, only like 4 GBs or 8 GBs, 16 GBs based on your requirement. And the machines will get significantly more expensive as you scale them up. So they are expensive and there is a limit to what you can naturally upgrade them to. Secondly, it is a very common design practice to not have your data persistent in cache. Caching is usually used to get some commonly used data faster. It is not supposed to be persistent. Your architecture should be designed to handle a situation where caching can go down at any given point in time, in which case your database will be returning the data directly, so it should be able to handle at least some load without depending on the cache itself. And it does happen so because this cache data is also stored on a server. It is stored in the memory of a server. It is not like our databases. It is not stored in any persistent memory. If that server is switched off and turned on again, the data will go away. That is the concept behind caching. That is where the speed comes in. That is why it is faster, because it is stored in memory. Alright, that is why it is not persistent, and that therefore we should think about what kind of data we want in our cache, and that is something to keep in mind. Thirdly, caching is a little complex to maintain because now you have two data stores to manage. First is your database, second is your cache. Alright, so it is a little complex to maintain, and especially if you're starting out with writing cache for your application, you will face a lot of hurdles. And that is why watching this video is important, because you understand some things to do or not to do. You understand the basics so that you can implement it as easily as possible. Alright. So it is a little complex to maintain, which is why you need to take a call on which resources deserve to be in the cache, which resources are okay with being fetched from the database itself. So if our cache is expensive, limited, whatever it is, we need to be selective, as I said. That means that we need to now talk about cache replacement policies, because as we write data inside this cache, eventually it will fill up. So we will need to find a way to evict the data that we do not need from this cache sooner or later, right? So cache replacement policies. There are a few that are commonly used inside applications. There is LRU, there is FIFO, there is LFU. This is just a lot of alphabets, I know. I will go through them one by one very briefly. LRU is least recently used. That basically means that let's say you have a situation where you can only store 1,000 items in your cache. Just an example. You can store maybe 10,000, maybe 1 lakh, doesn't matter. But the space is limited. So what will end up happening is that once 1,000 items are stored there, when you try to enter another item inside your cache in your key value format, the item that is least recently used, or basically the item that has not been called fairly recently, for example, if something was called from the cache on 1st April, another item was called on 31st March. The item called on 31st March is the least recently used for us, right? So that element will be evicted from the cache, and this new entry will now be called in and will be stored with the timestamp entry of 1st April. And this is the least, and this is the most recently used entry we have for us right now. So that is basically how it maintains the count of 1,000 without overflooding the cache, and it removes all the entries that have not been used in recent history. So it's basically based on dates. Then we have FIFO, which is first in, first out. That is as simple as it sounds. Whatever comes into the cache first goes out of the cache first, and that is just how it goes. You can use it to have just the data that has been put out recently in the cache, in the hopes that that will be accessed more recently. But there is a reason why this is not as popular as LRU. Same goes for LFU, which is least frequently used. So continuing with our scorecard example, if let's say we have space to just score 4 scorecards inside our cache, we will check which scorecard is being fetched more and more often. So if let's say India versus Australia is being called more often than India versus South Africa, and then we have India versus England now coming up, which is being called more than India versus South Africa again, India versus South Africa scorecard will be removed from the cache in such a case. Alright, so these are common strategies. It completely depends on your application's usage pattern, your processes usage pattern to be specific. And that is where you determine how to utilize your cache the best way you can. Now, I want to talk about this one point that I mentioned, that caching can be a little complex to maintain. Why do I say so? I said that is because you have to maintain it in 2 data stores now. One is the database, the other is the cache. Because try to think of a situation where you are using a social media application, you try to change your password, and let's say your password was successfully updated into your database, but it was not successfully updated in your cache. What will happen then? When we try to log in, basically, you will first try to get your data from the cache. And let's say there was some entry inside your cache for your user ID. You are able to fetch that data, but then you have to check your password, right? The password that is sent by you over here will not match the password that was sent previously and kept inside this cache. So you have to ensure that data is updated in this cache as well as the database. And that is why maintaining this situation can be a little more complex, especially if it is a business critical operation. For example, you're trying to maintain financial records. You're trying to maintain the salaries of certain employees. If they are updated in the database but not updated in the cache, some employee could get less money, which is again a matter of concern. So in such a situation, you have to be very careful on how you implement caching in your system. So there are a couple of ways to solve these issues where consistency is harmed, and that is where the cache write policies come in. So here we have a couple of policies. First is the write through cache, and second is the write back cache. They are similar in the way that ultimately what we try to do is keep the data between the cache and the database in sync. So write through cache basically means that whenever a resource is updated, let's say you're updating your password or your name or your email ID, that is sent from the client to the server. The server updates the cache and it updates the database at the same time. So basically, our cache and our DB are in sync, and that is good from the looks of it. And you would say that, okay, then why do we need any other policy? Let's just keep all of our data in sync, right? Well, we use this for critical requests preferably, when we certainly want this data to be persistent, and that is where this comes in handy. But you have to know that this makes more calls to our cache, and that can be financially expensive for your application, because caching of course costs money, right? Number of calls you make can the company can charge you more based on it. So you have to also think about whether updating data in the cache right then is necessary or not. For example, if we are trying to think about comments on any sort of social media platform, or let's say if I've made a post on a platform like LinkedIn and there is a small typo in my message, a spelling error, like it could be LinkedIn or Reddit or any other platform, and we want to edit our message or post, the final output, the latest output, does not really need to be pushed at that very instant in a lot of cases, right? Because if you're making a comment on Facebook, it's fine if it is updated a little later on. So that is where write back cache comes in, where you have again your client. Let's say you make an edit request, send it to your server. Your server updates it directly into the database, and it does not update it to your cache just yet. So how will the data be updated in the cache? When somebody requests for this comment or whatever resource is it, when there's a get request taking place, we will try to get it from our cache, but we will not find this updated data in our cache. It will be a cache miss basically. And that is where we check this data in the DB. We will find the updated data in the DB, we update it in the cache, and we return it to our user. That is when this data will be updated in our cache. So whenever somebody requests again, they can get this data directly from the cache without getting it from our database. That will make it faster. Alright, so you use a write through cache for better consistency, or if you just want your system to be more performant, so more consistency and speed, you want write back cache in your system if you're trying to reduce calls to cache, which would be a little cheaper to maintain. So that is basically your cache write policies. Now comes the question of what I discussed a little before. I said something like we could store our data in an in-memory cache or an external cache. Now, if you thought that I would not expand on this, you are wrong. I'm going to do exactly that now. So let's go further down. So we have in-memory and local cache, or external and global cache. All right, let's understand the differences and when can we use either one. So by default, in-memory or local cache would be faster. It would be faster but it comes with a lot of cons, especially when you want to scale up. So what happens is that if you just have one server, it is still okay to do so. It's still okay to keep everything in that very server, your application logic as well as some of the cached data. But the problem arises when you try to scale horizontally. And if you don't know what horizontal scaling means, I already have a video on it out, so you can check that out. You will understand what I mean by horizontal scaling. For now, just understand that we have multiple servers with the same application logic to distribute our application's load. We are making calls to all of them. Now, what will happen in caching locally is that some result will be fetched from the database from, let's say, S1. We have S2 and S3. Some result will be fetched from the DB. It will be cached only on S1. It can't be cached to all these other servers because they don't communicate with each other, right? They just communicate with our client. So this result will be cached somewhere over here. But when this client makes another request and it happens to go to some other server, it will again have to request this data from the DB. And if we have 3 servers, it's still okay. But if you have 100 servers, it kind of makes the whole point of caching useless, because now you're just making constant calls to DB and updating it in every server whenever there is a request. What we need for this solution is an external cache. We need an external cache, and we can use something like Redis for this. I'll just show you the website just to give you an idea. We have redis.io. It's a very popular company. It's a very popular tool, and you can use this in your application for caching, and a lot of companies use it for their caching solutions, and it has a lot of different implementations that can satisfy many use cases. So you can go check that out. And Redis is a popular solution. There are many more such options available in the market, and I'm just talking about one of them. So what will happen is that when we try to fetch data from this DB, it will also update in our cache and return to our server. So whenever this other client is now calling this second server, it will directly fetch this data from the cache without the need to go to the database. All right, so that is basically helping us to expand horizontally. There is also less downtime associated with an external cache, because these companies, Redis, they have mastered the art of maintaining caching systems. So they know how to back up, they know how to basically implement a solution in such a way that there is least amount of downtime possible. But if you cache your solution on your server directly, even if you have just one server, let's not take a case where you have multiple servers. Even if you have just one server, what will end up happening is that servers crash from time to time. Sometimes an overload happens, electricity goes off, could be anything. In such a case, all of this data inside your caching will also go away, because again, it is not persistent. All right. So you have to keep in mind that there will be a little more downtime associated, and when the downtime is resolved, your API will still be a little slower because it will need time to get this data back from the database. All right. That's another thing. Then external or global cache is also useful when you are dealing with microservices, because if there are multiple services trying to get some information, for example, if you have a comments service in your architecture, if you have a service that deals with posts on social media, both of these need information of the user. All right, so you could have this external cache where some of the user data, like their username or their email, is cached, and both these services can access it directly from the external cache, because the servers for each service will be different. One server is not supposed to have both comments and posts logic, and so it makes sense that we have this in our cache externally so that both of them can access it readily. And that is basically the concept behind caching. Now, I've talked about caching in the way where backend systems are optimized, but that is not the only use case of caching. You can use caching for, of course, computation, as I already mentioned. You can use it to reduce computation, make things faster. You can also use it for HTML pages. You can use it for images. You can use it for even videos or any other form of media that could be GIFs or SVGs or any sort of thing that could basically be delivered to the user faster. This is basically delivered via something called a CDN, a content delivery network, which I will probably cover in another video. So you can just stay tuned and follow this channel for more of such content. And we can even use caching in other use cases, except just a key value pair. You can have something called message queues. You can have something called message queues, where basically you can have tons of data. Let's say you have tons of data, ordered data. Let's say it's ordered by timestamps. You can divide this into chunks, and each chunk can be sent one by one to a message queue, where it is kept in an ordered fashion and then consumed in an ordered fashion. And that is another reason, another use case for caching. And you can use something called Kafka for that, if you are familiar with it. And that is something I'll make another video on. So again, just stay tuned if you're interested in that. And what I'm trying to say is caching is used in a very widespread manner. So it is not something that you can ignore, especially if you want to become a 10x engineer, especially a 10x backend engineer. So you have to keep that in mind. And that is all that I want to talk about in this video. I will see you in the next one, where we discuss more interesting system design concepts. So stay tuned and follow for more.